Meeting is being recorded.
Hello, everyone. This is the Istio User Experience Workgroup meeting. It's been several weeks. We were out because of KubeCon last week, or 2 weeks ago, and then the holidays. So I wanted to sort of catch everybody up. Last meeting, we discussed our working group's roadmap for 1.5, and we took those notes down here and discussed the things that we wanted. And I have tried to put all of the things that we discussed into a roadmap and assign P numbers to them. I am still connecting them to issues, but if anyone has a item that they think it's too low or too high or wants to connect it to an issue they're already working on, do that. I think it's editable. I'm not sure I want to go through because it is we went over it 2 weeks ago, and it's basically plus P numbers. The big thing we wanted to talk about, which we've been waiting for, is the mesh troubleshooting design and API. Romain, are you on?
Laptop, but I think we found a solution. Can you hear us?
I can hear you.
Okay. What do I present?
There's a picture of a box with an arrow going up out of it. It won't make you restart depending on your security of your system. I can see something.
Do you hope it's the right thing?
So far it's black. Now I see the screen. Yes, I see the document. Great.
Awesome. On the first try. Pretty good. Okay. Let's see. Yeah, I can't see anymore. Can you see on the left?
Now it's black.
Yeah, sorry about that. I need to. Yeah. Something to share on the screen here and it's kind of messy. Okay. I think we're back. Thanks a lot. This is it's been long overdue. I apologize. The purpose of this design is to basically replace kubectl exec. So I have two documents in there. There is a mesh troubleshooting architecture, and there is another document with a more precise API for the first version of the API. So what we want to do here is to replace kubectl exec because well, it's not super secure in production for support. This is not a viable solution to troubleshoot meshes, and this doesn't work on VMs. And I know there was a discussion a few weeks back in the working group about how to troubleshoot VMs, and this would be a solution to troubleshoot both pods and VMs. The overall idea is the following. So we will add a new API to Pilot, a gRPC API, where Istio could connect to it and do troubleshooting operations. And what Pilot will do is basically fan out the troubleshooting operations to Pilot agent, which will then interact with Envoy or run curl commands, that sort of things inside the pod. Right, so Pilot will be pretty dumb. It will just fan out the operations, do a scatter gather, collect back, and stream back the results to the client. And so the kind of operations we're thinking about is, so everything we use kubectl exec for right now is restarting proxy systems, changing log levels, dumping information, running curl to test connectivity, test certificates, that sort of things. And there's already people talking about many more use cases, such as doing security scanning, doing TCP dump like use cases for getting traces. So this is something that we see as pretty extensible. And we'll start with these use cases because these are what we use kubectl exec for right now. main
Before we get to the use cases, the security model. So the communication is a port forward, or how is the communication set up?
So you have pilot agent will connect to pilot. That will be TLS, and the pilot agent will authenticate pilot via its certificate, and it will authenticate to pilot with its Kubernetes token.
So the same Kubernetes token that we use now for the kube control exec will be used.
No, this is the token from the pod.
Okay.
I'm looking at the connection between pilot agent and pilot here. Okay.
Not that connection. I mean the connection between Istio Cuddle and this pilot. I wanted to make sure that nothing is that we're not. So right now, to use those commands, you need to have the authority to kubectl exec, and I was just wondering what Kubernetes authority would be used and how pilot would check that.
So that's an open question because we just don't want to do authentication, we want to do authorization. And just relying on tokens will not give us that. It will just do authentication here. So, so this is actually a problem that goes beyond the troubleshooting API itself because we currently have no APIs that require end user authentication and authorization. I want to think about it in a more general term, and I don't know if Ame is on the call, but there are solutions based on Vault, for instance, to do authorization. So I don't have a concrete design yet about that, and I will need to continue working on that. The use cases are a little tricky because, for instance, we want to take a GKE like a hosted Istio use case where you have a customer running a GKE cluster and we want to, a customer wants to grant temporary access to a Google support engineer, right, to access the API. How do you do that? How do you give like a token or something that has a limited lifetime? I know Vault can do that kind of use cases. We need to see how that could translate into an API, a generic API. So that's a bigger problem, and I admit I don't have a solution yet, but this is something I agree we need to work on.
Okay.
And I think that will go beyond whatever mechanism we come up with for authentication authorization should be something that's reusable for other APIs. I suspect that we might have other APIs in the future. So this is something that we should do in a generic way. I think to get started, one thing we can do is maybe just use the Kubernetes token and have a whitelist of users configured in pilot. See what I mean? Have maybe an environment variable with just a list of users that are authorized to do all operations, and that can get started, right? And then it gives us a little bit of time to do something better. Does that make sense?
It makes sense to me. We'll have to make sure the security group agrees with it, but okay.
Okay.
So show us the functional stuff, the API.
The API, yeah. And I go again. You see this?
Yes.
Okay. So this is a more concrete API. So I wanted to validate kind of the access patterns. So I have only two operations in this document, which are retrieving the config dump from Envoy and modifying the log levels. So this is kind of representative of the operations we will have. Either it's gathering a lot of data or it's doing a configuration of Envoy. And it also illustrates the link pattern reply. So I'm using the API's link patterns, link replies, sorry, to kind of scale better. Because this is a mesh-wide API, so it's like you can apply an operation to potentially all the proxies in your mesh, which is a lot of things. So if you do a config dump of all the proxies, it's a lot of data, and I don't want to have one giant protobuf with the config of everybody. So we will stream the responses back from the proxies. So the global API looks like this. So it's a gRPC service, and there will be one RPC for each management operation. And so there is one request, and there is a stream of responses. And we will get one response for each managed proxy. Right? So all operations will have the same pattern. And so that's the API between Istio Control and Pilot. And between Pilot and Pilot Agent, it's a little different because because the connection is in the other direction. So we cannot use directly RPCs that way because Pilot Agent is the client, the connection client, but Pilot is actually what sends the request. So here we have a bidirectional stream. So we have a stream of requests coming. So it's a return stream, right? It's a stream of requests from Pilot, and you have a stream of responses from the Pilot agent. And so each request has a request ID. We have a timeout to bound the duration of operations. And it's a one-off with the different operations that we do. Responses is the same. We have the request ID to kind of link the response to the request. We have a one-off of the responses. Depending on the operation, we have a different field set. And this is where link replies come in. So if we have multiple responses for a request, we have multiple responses with the same request ID. And to know when we are done, the last response will have this Boolean set to true. So that's a linked reply pattern. So one operation is Pilot. To do the fan out, it needs to know which proxies are managed by Pilot agent. Right now it's one agent, one proxy, but in the future we want to have multiple proxies for one agent, to have one agent per node. The one operation is for Pilot agent to advertise which proxies it's managing. So it will have this one response, which is updated managed node. That's the first thing it does when it connects. It sends this message here, which is just a list of. Can you share? Okay. Give me a second. So we have this update managed node, which is just a list of managed nodes. So it's a list of the pods here, all the metadata about the pods that are managed by this agent. And okay. And all the operations, so they can apply to an arbitrary set of agents. So when you do Istio Control, you will be able to say, okay, which subset of proxies you want to apply the operation to. And that will be done with selectors. So you can select whether you want to apply on sidecars or gateways. You can select the namespace by label eventually. You can select the pod by name or by label and by service account. The first operation will be to get the config dump. So here's how it looks like. So what Istio Control will call is get config dump. It will send a request, which actually I think it contains nothing. It just contains a node selector, which selects which proxies I want to get the config dump from, and we will get one response for each proxy. So the response will contain which the metadata about the proxy from which it comes from, and the config dump. So this is a protobuf defined in the Envoy API.
Would this be getting the config dump that Pilot has, or would it be getting it from the pod itself?
From the pod itself. So the idea is the source of truth is the data path, right? And this will go down to. So when Pilot will receive this troubleshooting request, it will just fan it out to all the Pilot agents, right? And the Pilot agents will stream back a bunch of troubleshooting responses, a bunch of those config dump responses here, right? For each of the proxies managed by that agent, and this will just be forwarded back by Pilot. So this is not querying Pilot. Pilot is just a fan out mechanism here.
So I was thinking of that debug command we have that compares what Pilot has versus what the Envoy actually on the sidecar has. And I was just wondering, usually we think of there being a pilot and some pods, but of course, when there's a lot of instances of pilot or of the pilot agent in these pilot pods, there's going to be a lot of instances of your pilot.
Mhm.
Your name pilot is perhaps troubling. Perhaps it should be like pilot debug or pilot mesh debug or something so that I can say what it is without confusing between the pods. But so when we do a gRPC, is the intention that your pilot piece, Istio does a gRPC to a pilot service, which has your pilot piece, and that is talking to all of the pilot instances? Or
Great question. This is so actually each pilot is pretty much stateless, right? We don't cluster the pilots. So when you talk to one pilot, when you do an RPC to one pilot, it will fan out to only the agents that are connected to it. Okay.
so, but think about that first picture that you showed. How do I gRPC? Do I need to set up a gRPC connection to all of the pilot pods?
Yeah. Yes. And to know which those are, there is an extra operation which is get servers. And because the pilots know actually about the other pilots already, so they can here you do this RPC to any of the pilots, get servers. That pilot will return you all the servers, and then the client will connect in parallel to all the servers and do the troubleshooting operation. It will do an RPC to every pilot. So it's a scatter gather from the client side, from Istio.
This seems like a complicated dance, but maybe it's better. Currently, we kubectl exec into each instance, which could take a long time. Do we think this is going to be good performing?
Actually, yes. So we here we had some debate about that. Okay, how do we do that? So we were initially thinking about having pilot itself do the fan out to the other pilots, and it's just simpler to do it on the client side. And it parallelizes all operations. It's not much more complicated for the client. It just needs to do one more operation to get the servers, and then do one RPC to everybody. And instead, let's say you have 9 pilots. So instead of getting one stream of responses, you get 9 streams of responses. It's not terribly more complicated, right? And it removes complexity from pilot. Kind of one objective with the design is to keep pilot really dumb here, right? Pilot has no state. The only state one pilot has is which proxies am I connected to? Yeah, pilot agents, right? And that's a soft state. And the only thing it does is fan out the request and stream back the responses. So it keeps pilot really dumb, which I think is a nice property, personally.
The other advantage is you spread out the resource consumption. Right. If you have it all going through a single pilot, then at some point, all of that memory, storing it in memory, is going to be used in a single pilot.
Yeah. Are you convinced, Ed?
It makes sense. Yeah. Okay. Continue.
Okay, so I was talking about getting the config dump here. So one thing, like just to simplify the first version, is like one proxy is one response, and it might already be too big. We will see how it goes at scale. Config dump is pretty big, so one protobuf per proxy might already be too big. So we may get into either doing filtering, so selecting what kind of information I want from the config dump, or splitting that protobuf into multiple protobufs per proxy. We'll see with measurements how it goes. And this is probably the worst API that we will implement, except maybe for TCP dump, because that would be even worse. But
do we need like to implement stress and other?
we can go crazy after that. We can, yeah. We could do a stress. We could do. There is profiling also in Envoy. We can do a bunch of things from that one, right?
So
Go ahead.
I had thought this API was only going to be for Istio features like Envoy configuration and the pilot stuff. Did you just suggest that we would also be using this for strace and TCP dump?
Some people are thinking about it. I would like to focus first on what we use kubectl exec right now, but I don't think we should be limited to that.
Okay.
TCP dump is an Envoy feature because there's a L3 tab which allows you to process to a TCP dump.
Oh, I didn't know. That sounds good. Okay.
It's not TCP dump, it's still an Envoy thing, right?
Yeah.
Okay, and the other operation I want to do in the first version is changing the log levels. So this one is much more lightweight. The request will contain, the pairs of logger and log levels that we want to set on the proxies. So the request will have it will have a set of managed nodes you want to do it on, and the response will be okay. What are the log levels set up for all the loggers? So that's much simpler API here, much more lightweight also. Any questions about this one? I don't think there's much contention about this.
Log name or do we need to specify the module of onboard connection
This is a logger name.
or log name?
Yeah. And this is kind of extensible, so it's just a string here. I don't think we should do an enum. Liam asked me the question this morning. I don't think it should be an enum because it will change by version to version.
Okay.
So the way that the client can discover what are the logger names is you will do a request with no log levels, which means don't modify anything.
Okay.
And it will return you the current log level. So here you will see the list of all the logger names, and then you can do a second command with just the logger names you want to change.
So all of this looks reasonable. Tell me, do you have an implementation of this?
Nothing.
Okay. And are you planning on implementing this?
Yes.
If it's approved. And are you planning on implementing it for Kubernetes or also for VMs?
This will work for everything because it's a pilot agent, so this will work with everything.
So the new pilot piece, the connection between Istio Cuddle and this piece, it's not a port forward. There'll be a new Kubernetes service that'll be exposed through a gateway. How will the, or will it be a port forward? How does the gRPC dance get set up?
I do not know. That's a good question.
If there's maybe there's already a SSH tunnel, if it's in the case of a VM or a port forward in the case of Kubernetes.
Well, you need for Istio, you just need access to pilot, right? So VM or container, this is relatively irrelevant. Yeah, it's. I guess you can configure a gateway to access pilot if you don't have direct access to pilot already.
I mean, it has to get the Envoy has to reach pilot somehow, anyways, right? So.
Yeah, it has to connect via XDS. That's why it doesn't change really. The network policy will not be very different.
I'm just wondering about the security and aspects of how we expose that. So I want to see more in the future about the connection between Istio Cuddle and other tools and your new piece, just to make sure that I understand the implications of security for opening this piece up. So right now, you need kubectl exec permission to do it, which is a high-level thing. If we're going to use a different mechanism for granting access, we need to understand it, or at least I do.
Romain, quick question on the performance implications of this on both pilot and pilot agent.
Yep.
So there will be a net new connection from the agent to pilot. That means apart from XDS, there are as many new connections as there are for XDS, right?
Correct.
Okay. And have you thought about what abort semantics will look like because this is a gRPC, you can have weird behaviors here where Istio CTL client might have gone away and Pilot is still trying to gather information and stuff like that.
Yeah. Yes. But this is really the communication cost is only when the user is actually doing an interactive troubleshooting operation, which is not supposed to be a regular thing. So the cost, like the kind of the constant cost, is really the cost of maintaining the connection open, right? And yeah, we need to measure that, but this is a priori the only cost. You say, yeah, maybe there are some cases where Istio control, okay, it makes a command, it goes away, but this is supposed to be an interactive troubleshooting tool. And this is not something that will be done, like say, every second by an automated tool. This is an interactive troubleshooting API, right? All the use cases that we had were really about, you know, like you have found a problem and for instance, with telemetry, you found a problem and then you want to dig in, right? And that's a user interactive operation. So yeah, and they will be okay to pay the cost, I suppose, in that case, right? You want to get the config dump, yeah, it's a lot of data to retrieve. That's an interactive thing, and you're willing to pay the cost for that. So yeah.
I see.
Does that make sense?
It does. I was thinking, is there any other architectural option to reduce the extra connection? As in, can we shoehorn this into XDS somehow?
No, we can't, because XDS is from Envoy, and the point of this is to manage Envoy. So this is to be used when Envoy is wrong, when something goes wrong with Envoy, right? So that's the whole point. So you cannot, this is a management system, and Envoy is a managed system. So it needs to function. But in the future, because so we want to move to CRA proxy at some point. This is a different discussion, but we can have one agent per node, which will reduce a lot the number of connections. Let me share.
Thank you for all this work, Romain. Liam, did you have any questions about this?
We've been discussing out of band, so
okay.
I've asked all my questions there.
Okay. Should we come back and review this again in 2 weeks? Should we all go read it more thoroughly and post more questions on the item?
Sounds good to me.
Okay. Thank you, Romain.
You want to see something about security, I suppose, in 2 weeks, right? I'll try to get something out by then.
Okay, thank you.
Thank you.
Okay, hopefully I'm sharing again. I briefly wanted to mention KubeCon and hear if anyone saw anything that they think should be presented here or shown here to other people in terms of ideas for things. I mentioned 2 talks that I saw. One was a very short, I think it's Service Mesh Con by the Linkerd guy, William Morgan, where he presented a new thing that's in a closed beta. I haven't seen the actual thing except for his demo, which he calls Dive, which he calls Facebook for Services. I don't know how it works, but I was very intrigued by his description of Facebook for Services, and I'm imagining, a user sort of logging in and seeing that 2 of his microservices have a complex relationship today, whereas they had been recommitted yesterday. The other talk that I really liked was Matt Turner's talk, where he shows how to use tools like Istio Cuddle Analyze and other tools to debug RBAC problem in Istio. I thought that was a very good talk. Did anyone else have anything that they saw at KubeCon they want to mention?
The DoD talk mentioned that they're running Istio on an F-16. I thought that was pretty exciting.
Or terrifying, depending on how you look at it.
Yeah, exciting doesn't necessarily mean positive, but exciting nonetheless.
True.
Don't think about it, Liam.
didn't see the DoD talk, or I saw a few minutes of it at the end. Should I watch it on the video? Is it good?
Yeah, I mean the slides were DoD slides, kind of a wall of text. But the journey of using Istio for multi-cluster across the F-16 to manage services and to manage the ability to securely communicate off-platform was very interesting. He gave a great plug, which is if Istio is secure enough for an F-16, it's secure enough for you, which I think a lot of the audience liked.
Excellent. Thank you. So I was talking a bit with Greg about ephemeral containers in Kubernetes 1.16. And he suggested that they would be a good candidate for allowing us to remove a lot of the stuff that we put into Istio proxy, like curl, to make a smaller footprint, more secure proxy, and then you would dynamically attach this debugging container. Greg, are you on? Do you have anything to talk about or any discussion on that we could have?
Yeah. So can you guys hear me?
We can.
All right. It's a combination of potentially trying to cut down on the size of the Istio proxy container that runs with each of the services in the mesh, and then also the ability to just add more debug tools available by default by having this separate debugging container that we can attach to an existing pod. We could add things for like TCP dump, for instance. I mean, that's the one that immediately comes to my mind, or even what was the one that came up at KubeCon that I hadn't heard before? The Istio access log parser. But I don't know. So I was kind of throwing it out there just to see if there were any other thoughts on useful tools that might be worth investing in, or if there's more things that people are aware of that we could take out of the Istio proxy container to potentially make it a little smaller footprint.
I want to point out at Matt Turner's talk, he shows how to use Wireshark with Istio, which I thought was cool.
Yeah, there were a few talks on, well, there was one specifically, like using a sidecar to debug issues in their service mesh. And I thought that they would be discussing something similar to this, but it was not making use of ephemeral containers in that presentation.
Greg, I think that sounds interesting. My question would be, do we consider this as something that would be under the scope of the UX working group, or should this be proposed to like the networking team or some other group?
Well, I figured I'd start with the this group just because if I know people have either heard about, well, hopefully heard about people trying to use tools to debug various issues, and either people complaining that they didn't work or just tools that the members on this call have used personally to try and debug issues within Istio. Yeah, so just trying to collect feedback in that regard. But yes, I agree. Yeah, networking would be one, or even scale and performance.
Or documentation to teach people how to do this. I will say that before I ever heard of ephemeral containers, I would create what I called non-functional containers, which was just a sleeping container loaded up with all my favorite junk like TCP dump. And at one point, I tried to make the auto injector inject this thing. And I struggled with that, probably due to a misplaced tab in YAML somewhere. But having all those tools around is awesome. Having them ephemeral so that you only pay them on the one pod you're debugging seems great. One thing when I was testing with my sleeping container that was loaded with tools that I struggled with was the certificates. We mount the certificates in the sidecar. So anything that was MTLS based, it was hard to test because you had to get those certificates onto that other debug container. So I think what this group might do is sort of just propose maybe some popular commands or encourage someone, maybe even a third party, to put in the Istio ecosystem their favorite ephemeral debugging container and show people how to use it with Istio. You could sort of incubate it rather than actually trying to write one or define one, unless you wanted to take on that job, Greg.
Potentially. I'm sure the scope of this investigation is ever changing.
I think it would be great if we can provide a replacement for debugging. I guess we only have one proxy now, right?
It would be
At one
great to
point
get.
we combine the debug and non-debug into one, but the proxy we have could be a little bit more lightweight. So if we can do one lightweight sidecar proxy, which doesn't need to include some of our debugging tool, and then we could ship a standard ephemeral container for that, and then on top of that, we can show people how people can extend that to their purposes to customize that. That would be really good.
It would be a big win for security and a good win for performance if we got Bash and curl out of that sidecar.
Yeah. And it helps over security vulnerability, scanning and all that too. And honestly, where I was listening to Roman spoke about the new mesh, I think it was the mesh debugging API. Honestly, I would only want that as on demand. I mean, I don't want the debugging API in my system. If everything works, if we can have that as a ephemeral container to pilot, that I would enable it when I need it, I think that would be really cool.
Well, that's a good idea, Lynn. I like that too.
Another thing too is just we're providing like a container that could potentially, just be dropped in and just run rather than us being able to tell users, like, oh, if you figure out some way to get a Wireshark and TCP dump, we'd probably be able to give you a better idea of what's going wrong with your system. Yeah, just being able to say, like, use this container. It has tools X, Y, and Z. These commands just work. You don't need to worry about, say, creating a service entry rule to be able to install the component that you want to in your pod to get the debug information that you want. It's just there.
I'm not sure these are mutually exclusive either, because this is kube specific, right? If you're trying to debug a sidecar running on a VM, you're not going to be able to spin up, well, you might be able to spin up an ephemeral container, but you need a specific persistent connection if you just wanted to work with Istio, right? That's kind of, so this is what Aspect Tetrate are interested in with regards to the debugging API, right? Is how do we debug data planes running on VMs?
But your pilot still.
How is that consistent with kube, right? How do we maintain a consistent way of debugging across VMs and kube pods?
Right. So your pilot would still run in kube, or your pilot would also potentially running on VM?
At the moment, it's running in kube, but potentially, right, it could be running in VMs. We haven't had someone specifically asked to run it in a VM yet, so
okay.
we haven't opened that can of worms.
Right, that's another set of worms for sure. Yeah.
We could start that ephemeral container on the VM if it had Docker with the networking, host networking.
Sure, but you're always making assumptions, right?
I gotcha. So let's think about that. But thank you for your comments, Greg.
I guess one other separate item too is I know, let's see, on that debugging Istio or debugging an RBAC problem with Istio talk, they pulled up that one Twitter picture.
I want to show that next, Greg.
Okay, all right.
Let me start that up now.
Okay, I'll hold my tongue.
This is so at one of the talks, he pulled up a tweet by Megan O'Keefe, which says, have you ever looked at Istio's proxy logs and thought, oh, and here they show sort of what the Istio proxy logs are like. And I looked at this and I realized I've also had troubles trying to figure out what these fields are. And if you watch that talk, if you go to at this exact time, I put the time link in, you can hear people laughing and stuff when they see this picture. So we can control this log format with the option global proxy access log format. And I saw a few weeks ago, about the same time as KubeCon, someone posted in Istio General Slack that they were trying to do this and getting weird errors. I was trying to do something similar and didn't get as far. I was thinking just that it would be cool to put something in tools or an Istio Cuddle proxy config log to ramp up and dynamically turn on and off these annotations, something like this. So I was hoping to get some feedback if we think it's worthwhile to have somebody spend a couple days and write some helpers or a blog on this.
One comment, going back to earlier days of Istio, we did modify the default Envoy access log to something more like what you have there with like field : value. And the comment was that there were, I believe, some concerns about scale and performance, just the fact that we're generating access logs, and as you scale up in an environment, you're adding that many more characters to the log, and so everyone that's generated is that much more memory.
Yeah, I put it with this global log config the way I'm proposing, does it to all of the envoys, and if you have 1,000 envoys and you're trying to debug one container, it's a pain. And I don't know how that we could send it just to a small subset. I, of course, want to turn this on my tiny test cluster that has just a few dozen book info pods for a few hours while I'm debugging some bit of multi-mesh junk. So that's what was leading me to try to do this. Have others been trying to do the same thing and having good luck, or?
So Ed, I think with the Envoy filter API, you might be able to customize selected pods or selected sidecars and just change their access logs.
Okay.
So if you're thinking about a tool like wrapping it as a istio-ctl command, that might be very interesting, right? So you can conditionally just turn on and off JSON logging for a subset.
True. I'm pretty sure Envoy supports that filter level Envoy format. It's just that that part isn't exposed in Istio right now.
Okay, anything else, or shall we move on? If you have comments, just, I guess, add them to the doc. I'm going to try to figure out what is desired. So added to the agenda, after I looked at it, this person added this canonical service proposal. And I didn't see this here, so I haven't talked to this person. How do I pronounce your name, and can you walk us through this proposal?
Sure. So I'm Daniel Otero. That's just my GitHub handle. Canonical Service is a proposal from me and Sven, and it's a proposal to try to address a fundamental object model issue that we keep running into when we're trying to design.
Can you share the document, or should I pull it up?
If you were already presenting, it might be easier for you to do it. My laptop is woefully underpowered for all this.
Okay, just tell me when to scroll.
Great. So yeah, maybe just put the overview on the screen. It's just a couple paragraphs. This doc really aims to be brief and to the point. So basically what it comes down to is that when we look at the critical user journeys, use cases, whatever you want to call them, that people who owners of specific services, application developers, whatever you want to label that role. Someone who develops and operates a particular service. When we look at what those people have to do, and then we try to map it to the Istio and the Kubernetes object model, we have Kubernetes services and we have Kubernetes workloads or Istio workloads. And neither one of them is quite a representation of the unit that someone actually is operating. There's a many-to-many relationship between all of these concepts. So based on all of our research, what we're proposing is effectively a one-step higher level of aggregation, which is one-to-many with workloads and services. And we have struggled for a long time with naming this thing, to the extent that I was referring to it as foo for the longest time. We've done a bunch of UX research, and we keep coming back to the term service. We're proposing canonical service to try to disambiguate from Kubernetes service and other interpretations of service. But we call out a list of a bunch of different naming suggestions that that we came up with, and actually solicit requests for other names that might be better. But the bottom line is the idea is to group up a bunch of these related resources, which all contribute to one logical service, one piece of business functionality that is deployed as a unit, which really maps to a group of workloads that may have one or more load balancers and host names associated with it. And we propose a standardized label, which allows the user to, and this would be a label that's put on workload instances, on pods, on the forthcoming workload entry, that would allow the user to tell Istio what the label is that they want attributed to all of those workloads. So the label we're proposing is service.istio.io. I guess you can scroll down a little bit. Let's scroll down to, proposal. That's great. So we're proposing a service.istio.io/canonical name label. So one standardized label. And the reason that we want it to be one standardized label is that we want to enforce exclusivity. We want to make sure that no pod, no VM is part of two canonical services. Everything should be exactly in one group. We want non-overlapping telemetry. On the managed side, we want to be able to do things like clear cost attribution. Then the other thing is we want to introduce new telemetry labels. So source.canonical service and destination.canonical service.
So
yeah.
If you could you give me an example? For example, if this was book info, would a canonical service be just product page, or would it be all of our microservices? What is an example of a canonical service here? Right.
So basically, the way to think about it is that in the modern cloud native world, typically speaking, the 90% use case is that a canonical service is going to be one Kubernetes service and one deployment in a particular cluster. So it's one logical group of functionality. So in book info, product page would be a canonical service, reviews would be a canonical service. But if there's reviews v1, v2, v3, that's ostensibly all part of the same canonical service.
Makes sense. And so we often canary between these versions or route traffic between these versions. You'd consider all the versions of reviews to be a canonical service.
Right. In particular, because you want to be able to easily ask questions like, for my canonical service, what is the distribution of traffic to all the different subsets? Or if you're not using subsets, if you're using literally different Kubernetes services and aggregating those all into one, what's the relationship between my traffic and my various different sub Kubernetes services? Right. So
quickly, you touched on clusters there. So if you have, say, two different kube clusters, different AZs, how does that then fit into it? Are those separate canonical services as well? Or are they all part?
So in keeping with the Istio idea that we within a mesh, we consider namespaces to exist across cluster, right? We assume that namespace foo is the same entity on every cluster in the mesh. Canonical service would be a namespace scoped entity, but it would be cross cluster. It would be namespace / canonical service would be a unique entity for the entire mesh.
So by namespace there, you're talking about Istio namespace, not Kubernetes.
Correct. Yes.
All right.
And so the other really important part of this is, again, we create these new telemetry attributes for source and destination canonical service, and we populate these attributes on all of our telemetry. And this is really the important part, right? Because we want to be able to ask questions about the telemetry associated with these entities. And without an attribute on the telemetry, we don't have a good way to query that. So if you scroll down a little bit more, yeah, let's look at details right here. Perfect. So one of the key things is that we want this to work out of the box and work well in the 90% use case with no user changes whatsoever. But we also want to expose a lever that allows people to say, no, the default heuristic isn't doing it for me. I think of my service like this, and I am going to apply my own label. So we create this label, service.istio.io / canonical service, canonical name. But if that label is not user populated, we populate it. And we populate it using a known set of heuristics in a known priority order so that we can guarantee that every single workload instance in the entire mesh has this label populated. And then if the user wants to override it, obviously they can override it. The explicit user set value trumps everything else. So the idea here is that for these common use cases, for instance, when there is exactly one Kubernetes service pointing at all of these different workloads, we can safely say, all right, well, we can all group these up under the Kubernetes service name. The problem is that there are many cases where that breaks down. So you can look at all the heuristics and please jump in on the comments. This is going to be reviewed tomorrow in the policy and telemetry working group. But I just wanted to make it available here. I think the reason I wanted to bring it up especially is I see this as being something that Kiali and other visualization tools would want to take advantage of. One of the big things that I think I can't speak for Kiali, but I would imagine Kiali is running into the same problems that we are on the Google side, which is it's very hard to build nice, simple visualizations and information architectures when you're trying to deal with all these different disjoint concepts that don't map strongly to each other. So for instance, the visualization that I know in Kiali of how traffic flows between these entities, they've had to make a bunch of concessions to show all of these different things as opposed to just being able to illustrate it the way that a human would draw on a whiteboard. So hopefully this will help with that.
So question,
yeah.
is the value of this is to save user from label their service name for telemetry purpose and the version?
To label
if you read Istio.io, if you go to parse requirements for enable your service to run within the mesh, we ask people to label their deployment, and we ask them to label their services to the name of the service. I think we also ask user to label the deployment to corresponding version, like review version 1, 2, 3. Yeah. So deployment with the app and version label. Are you proposing to kind of eliminate the lead for people so that they don't need to do this manually, so that?
No. So the app and version labels are sort of Kubernetes community standards, right? So a lot of people are going to use this, but this doesn't address the one critical thing that we're missing, which is we need this on telemetry. And so at its core, What we're saying is, so you'll notice the highlighted line, right? Check the app label. It's heuristic number 4. For people that have already adopted the Istio best practice, we want this to work out of the box. And if you've already given us a strong signal that that's the way that you think of your app or your service, we're just going to use that label. But the key part of it is porting that over to the telemetry, and
currently telemetry uses a random Kubernetes service. If there's just one, it will use that one. That's the issue we're talking about, right?
well, when you say uses a random Kubernetes service, what do you mean?
Well, I mean, normally, I think Istio may even have a rule that only one Kubernetes service should point at a workload.
Yeah, but I don't believe it's random though, Ed, because I think there are selectors you can use to find out which deployments are providing a service.
Right.
So the issue is that Istio offers a tremendous amount of flexibility, right? So it is perfectly valid for me to create multiple different Kubernetes services and join them together under a single host name and control the routing between those multiple Kubernetes services. And in fact, as an example, this is actually how Knative works. So if you're familiar with Knative, another open source serverless project, they use Istio, but they end up creating one Kubernetes service and one deployment per revision of a given Knative service. And so this would also be a grouping mechanism that would allow us to tie all of those resources together under one logical canonical service. Right. It's also perfectly possible to attach multiple Kubernetes services to a workload, in which case, how do you reason about that? And it's even possible to attach multiple Kubernetes services to multiple workloads in overlapping ways. So we've given people the tools to really make some complicated topologies, and this is just an attempt to simplify the model for us to build tools on top of, and also to make some strong recommendations to people about how to organize their stuff.
I think it's great. The name Canonical Service did throw me at first, though. Looking at these other choices, it's confusing. It's also interesting that we're talking about Knative, and I don't know if this will work with functions. If it's about telemetry, maybe we need the word telemetry in, like a telemetry service, or.
Well, I think the idea is, so right now, Canonical Telemetry Service actually exists in Istio, and part of the proposal is to piggyback on that. The reason that we're not calling it Canonical Telemetry Service is, frankly, this is a foot in the door. I think that we're going to find that this is a missing concept that's important for a lot of different things, and we're probably going to want to hang more on it than just telemetry. Which is part of the reason that we're starting with telemetry, because it's the low-hanging fruit, it's the clear use case. But I don't particularly want to pigeonhole it to just telemetry.
So Daniel, I think it would be really helpful if you can actually specify the use cases you mentioned. I think Knative is an interesting one, but I don't think the use case is so much relevant to using book info. Like Ed, you were trying to understand how this map to book info, because I think book info doesn't really have this problem. The other scenario I can think about might be interesting is if you're running maybe some of your services on VM and some of the same services in Kubernetes, and maybe you want to use you have external services point to the services running externally on VM, and then you can leverage canonical service name to kind of link the two together, even though they were provided from pods as well as from VM. So I think the user case would be tremendous helpful for us to understand, how our users will be able to leverage this. Because for now, it's not super clear to me.
Totally agree. And why request.host, for example, is not sufficient in various cases. If you can illustrate that, that would help me understand also.
Yeah. So one thing I realize we're out of time. But one thing that we've struggled with is that this is really a pretty foundational thing. If we union all of these sorts of questions, we write a 40-page doc. And so we've been trying to split the difference, make something that's consumable, but also obviously, we have answers to all of these questions. I don't know what the best way to communicate it is, but yes, I'll take that to Sven. See what we can do in terms of use cases for tomorrow in the policy and telemetry working group.
Maybe expand the rationale. Maybe we continue this tomorrow in the telemetry working group.
Cool.
All right, thank you very much. I'm going to end the meeting. Anyone has stuff for next week, or in 2 weeks, add it to the agenda, please.
Thanks, Ed.
Very
So
much.
Thanks, Ed.